Good morning, good afternoon everyone. Today we will learn the Miller indices as a new topic. Now what is the meaning of Miller indices? Miller indices are nothing but the smallest possible integer, means that all the indices in the form of integer just like 1, 2, 3, 4 etc. not just like a 0.5, 0.7, 0.6 etc. So, the Miller indices are the smallest possible integer which are equivalent to the reciprocals of intercepts along the axis. For example, suppose we are consider this is one of the plane. Suppose this is A axis, B axis and C axis. The intercepts along x axis as 1, along y axis as a 3 and along the z axis as a 2. Then what are the Miller indices, or what is the meaning of Miller indices? Now here in the figure we observe that the A intercepts of the plane is nothing but 1, y axis intercept is nothing but 3 and the z intercept is nothing but a 2. Now our aim to find out the Miller indices. Miller indices are nothing but in the form of a integer. With that our aim to find out the Miller indices of the given plane in the form of a integers. Now there are 4 steps to find out the Miller indices. Well, the first step is nothing but take the intercepts along the axis. Along the axis intercept, first step as the intercept. What are the intercepts along x axis? X axis is nothing but 1, second is nothing but along y axis as a 3 and along z axis is nothing but a 2. Then second step of this one, second step we will take here the reciprocals of intercept. The reciprocals of intercepts is nothing but 1 by 1, 1 by 3 and 1 upon 2. And the third step is nothing but we have to convert this integer or reciprocals in the form of a integer. That's why we have to take the LCM of that one. So the third step, convert into smallest possible number. The smallest possible number as 1 by 1, 1 by 3 and 1 by 2. The LCM is nothing but here 6. So the first smallest possible integer is nothing but 6. The second one is nothing but here 3. The first factor is, second factor is nothing but 2 and the third one is 1/2. So here we will get the third indices is nothing but a 3 and the fourth one, step 4 is nothing but close in parenthesis or enclose in parenthesis. Enclose in parenthesis means those we are finding, that is 6, 2 and 3. These are the Miller indices and all these are in the form of a smallest possible integer and these are equivalent to the reciprocals of intercepts along the axis. That's why the Miller indices are always in the form of a integers. Now how to calculate any number of intercepts are given. For example, suppose we are considered calculate the Miller indices for the intercepts along the x axis as a 2a, along the b axis, y axis as a 3b and the z axis is parallel to the both the axis. At that time what is the third one? Third is nothing but parallel to the axis. So the Miller indices, how we can calculate? By going through the all 4 steps. What is the first step for the Miller indices? The first step is nothing but take the intercepts along the axis. Here A, B and C are given, that are nothing but the unit vector. Our aim to find the Miller indices, that's why first of all we will take the intercepts along the axis, that is nothing but 2, second one y axis is a 3 and z axis is parallel to that one. Parallel means that the intercepts at infinity. So, the Miller indices we can calculate in the form of a 2 intercepts of that given plane is nothing but 2 as to 3 as to infinity. Now, what is our second step? Second step is nothing but take the reciprocals of that particular index. The intercepts along the corresponding axis 1 by 2, 1 by 3 and 1 upon infinity. So, the third one we will get the convert into the smallest possible integer, that is LCM is nothing but 3. So, here 1 half integer is 3, second one is 2 and here it becomes a 0. Now, the fourth step is enclosed in a parenthesis, that is a 3, 2 and 0. These are the Miller indices for a given plane for 2 as to 3 as to the parallel to the each one. Next one, crystal plane and crystal direction of a given Miller indices. For crystal plane and crystal directions of a given plane, crystal planes and directions. First we see that about the crystal plane, how to draw the crystal plane. First of all, we have to draw the crystal structure, cubic crystal structure, as all sides of this cubic crystal structure are nothing but a same one. Each side of the cubic crystal is a same as a lattice parameter A. This one is also A, this is also the A. Now, our aim to find the crystal planes. The crystal planes in 3 forms. The first one is nothing but 1 0 0, second is 1 1 0 and the third one is nothing but 1 1 1 plane. Now, how to draw these all these plane? First of all, we will see about the 1 1 0 plane. So, first of all, we have to calculate, draw the cubic crystal structure and then corresponding axis. Label the axis properly X, Y and the third one is nothing but a Z. Now, our aim to find out draw the plane as 1 1 0 plane. The distance from that origin to the corresponding axis for all edges of a cube is nothing but unit distance. So, the intercepts for that particular plane from origin to the corresponding x axis is the unit one. So, the x intercept is nothing but 1, y intercept is also the 1 and the third intercept is 0. So, we cannot consider 1 1 0 plane. The step is 1 by 1, 1 by 1 and 1 by 0, that is 1 as to 1 as to infinity. Now, the third axis as infinity, so that cannot be becomes in our crystal structure as infinity. Now, we take the intercepts along x axis, intercepts along y axis, both are 1 1 and the third axis at infinity. So, 2 points we will get, we will join those 2 points and one here we will get a single straight line and single straight line cannot represent a plane. So, we will consider the opposite plane of the given crystal structure and draw the same type of a parallel line to the x and y plane. Now, shade that portion and we can say that the shaded portion can be acts as a 1 1 0 plane. For example, here the crystal model we are considered. In crystal model, there are three axes, x axis, y axis, and the third one is nothing but a z axis. Now here we observe that the x intercepts of the plane is 1, y intercept is 1, but the z axis as a 0. That's why here only the one line we can get from the intercepts of x and intercepts of the y, and the single line cannot represent a plane. That's why we will consider the opposite plane of that one and draw the parallel line to the particular plane. So there is a formation of a crystal plane as a 1 1 0. Similarly, we can draw the crystal plane for a 1 1 1. Now how to draw that crystal plane for 1 1 1? Again draw the particular cubic crystal structure and label the axes properly x, y and z. Now here 1 1 1, 1 1 and 1. These are the given Miller indices, 1 1 1 are the given Miller indices. Our aim to find the intercepts. Intercepts are nothing but the reciprocal of that one, and that reciprocal of that one is 1 as to 1 as to 1. So here the x intercept from the origin, we will consider from origin the x distance is a 1, y distance is 1, and the third one is nothing but a z distance, that is also the 1, and join all these 3 points and there is a formation of a crystal structure. Now here shade that portion of all 3 points, and here that shaded portion can be acts as a 1 1 1 plane. Now here the one of the crystal model of 1 1 plane, actually these are the number of parallel plane. Here we consider this is x axis, this one is y, and the third one is a z axis. The x intercept is 1, y intercept is 1, and the third intercept is also the 1. So the plane can be acts as a 1 1 and 1 plane. Now this is about the planes are 1 and 0. Suppose we will rotate the same crystal plane. Suppose this one is nothing but 1 1 1 plane. Suppose we will rotate that one. Now here this is our x axis, this is y, and the third one is a z axis. The x intercept is 1, z intercept is 1, but y intercept is a 0. So when we will rotate the 1 1 0 plane, after rotation of around the crystal structure axis, then we observe that the plane can be changed from 1 1 0 to the 1 0 1 also. And how to draw this 1 0 1 plane? Exactly similar way we will draw the crystal plane. First draw the crystal, cubic crystals. Label the axis properly. This is x, this is y, and this one is nothing but a z. Now 1 0 1 means that our x intercept from the origin is nothing but 1, intercepts along y axis is 0, and intercepts along the third axis z axis also the 1. Now we will get join these 2 points and we will get a straight line, but that single straight line cannot represent a plane. We will draw the parallel line to the opposite plane and join all these 2 points to each other. There is a formation of a 1 0 1 plane. Now whenever we will draw the plane, there is essential that we have to draw the first of all crystal plane, then label the axis properly, and those Miller indices are given, take their reciprocals, because the Miller indices are nothing but the smallest possible integer and which are equivalent to the reciprocals of the intercepts along the axis. That's why here we have to take the reciprocals of the each one. Now this is about 1 and 0. Suppose the planes are given or Miller indices are given more than 1 and 0 number, just like 1, 2, 3 plane or 1, 2, 1 plane, suppose we have to draw. Now here this number not in the form of a 1 and 0, Miller indices in the form of 1, 2 and 1. So how to draw this plane? First of all, take their reciprocal 1, 1 half and 1 again. Then draw the again crystal, cubic crystal. Label the axis properly, x, y and z. Consider origin. Now our aim to find out 1, 2, 1 plane. So the x intercepts in a cubic structure is a 1, y intercept is nothing but half of that one. So the half distance we have to take along the y axis, and the z axis is nothing but again the 1. Then join all these 3 points and shade that portion, and that shaded portion can be acts as a 1, 2, 1 plane. Means that if the numbers in the form of 1 and 0 or the numbers in the form of 1 more than 1 and 0, then also we can draw the plane. Now the same type of plane we can draw if the numbers given or Miller indices in the form of a negative. Now how to draw the negative plane? Suppose bar 1, 1 and bar 1 plane is given. Miller indices of a planes are given as bar 1, 1 and bar 1. Our aim to draw the negative plane. For negative plane also same type of cubic crystal structure our aim to draw. Now for negative plane we cannot take this one as a x axis, this one as a y axis and this one as a z axis. Here essentially that we have to change the origin from the our normal origin to the at any 8 corners of a given cubic crystal structure. So we will change the origin from here to here. Suppose this is our O point. The first axis, suppose we will consider this one, second axis we will consider this one, and third axis is considered as a upper side. So now label the axis in such way that these all 2 negative points come inside the unit cell. So here our aim to find out minus of x. So suppose we will take here x, here we will get as a minus of x, or generally which is denoted as also minus of a, because the intercepts along x axis as a, intercepts along y axis as a b, and intercepts along the z axis is nothing but minus of c. So the x axis and the z axis both points come inside the unit cell. So we will change our origin from here to the one of the corner of a cubic cell. Now here minus a we will get, minus c is there and plus of b, and joined all these 3 points and we will get as a minus negative plane, as a bar 1, 1, bar 1. Now there is also one method to draw the plane. Suppose in a given Miller indices minimum 2's are negative, generally we will shift our origin to the right corners of a unit cell. Suppose the single one as a negative, then we will shift our origin, that is very easy to draw on that particular axis shifting. Now generally this is our origin. Now our aim to find out bar 1 plane. In this plane single 1 is a negative, that's why we will shift our origin from here to the here. So here one axis, this is second axis, and this one is our third axis. Now what is the negative one? Negative is nothing but y axis. So those one is a negative, we will take here. Suppose x is a positive, we will take this one is x and this one is a z. Now here bar 1 1 is the along x axis, bar 1 along the y axis, this is the positive distance, so this distance is nothing but a negative 1, and the positive distance along the z axis, that is a bar 1 and 1. Now join all these 3 points and again shade that portion, and we will get the negative plane. I think that everyone understood about the how to draw the positive plane as well as a negative plane. Now we will draw the crystal directions. For crystal direction in 1 and 0 there are possible. In a single unit cell we can draw the 7 crystal direction, that is 1 0 0 0 1 0 0 0 1, then 1 1 0 1 0 1 and 1 0 1 1, and the last one is nothing but 1 1 1. Generally the planes we will represent in a round bracket and the directions we will represent in a square bracket. Now for drawing a directions of a plane, again we have to draw the cubic crystal structure, label the axis as properly x, y, and the third one is a z. Again here we will take as a origin. Now directions are nothing but the perpendicular draw to that particular plane. In a single unit cell, suppose we have to draw the 1 0 0 direction. Now here in a cubic crystal structure we already know that from origin to the corresponding axis distance is nothing but unit distance along x axis, along y axis, along the z axis. So we will draw the perpendicular from the origin to that particular axis. This distance is nothing but 1 here. The coordinates of this point are nothing but x axis is 1, y axis coordinates are 0, z axis coordinates also the 0. So the directions of a plane can be represented with the help of arrow from origin to that particular point. Similarly, we can find the coordinates of this point. Here only y is 1 and both are nothing but 0. So the second direction as a 1 0 1 0. The third one, what are the coordinates of this point? Only z is 1, others are 0. So draw the perpendicular from origin to that one, we will get 0 1 0. Now what are the coordinates of this point? Here x is a 1, y is also the 1, but the z coordinates are nothing but 0. So the direction is a 1 1 0. Draw the perpendicular from here to here, that is a 1 1 0. Now here this point we will get x is a 1, y is 0 and the z is 1. So the directions of this one is 1 0 1. Draw this perpendicular. Now coordinates of this point is here x is a 0, y is 1 and the z is 1. So draw the perpendicular from here to here and the direction is nothing but 0 1 1. Now the last point here, x is 1, here y is also 1 and the z is also 1. So the direction of the plane is nothing but 1, 1, 1. If the directions in the form of 1 and 0, then we can draw in a simple way the directions of a plane. But the numbers are given more than 1 and 0, like 1 to 1. Draw the directions of a 1 to 1. For 1 to 1, again we will draw first the crystal cubic unit cell. Label the axis properly, x, y and z. Now there are one method to draw the crystal direction if the numbers are more than 1 and 2. The first step is nothing but divided by the maximum number comes in a Miller indices. That is here 1 to 1. The maximum number is of 2. So we will first of all divided by this one by maximum number as a 2. So the first coordinate will get 1/2, second is a 1 and the third one is again 1/2. Now we will find out the directions or the coordinates of a 1 to 1 in a cubic unit cell. Now how to draw? The first intercepts of that one, x is nothing but 1. So this is our origin, x axis, y axis and z axis. The x axis half distance is there, so we will take the half plane and draw the half plane of x axis. Now second, y is 1 and the third one z is also 1. Now here one thing also we have to remember that if those coordinates becomes a 1, that axis we will take in a upper direction. So here first we will convert this one is a z and this one as a y to z and here z to the y, because here all the points come in the form of a 1. Now second one is a 1, y axis coordinates is 1, here this whole plane acts as a 1 1 1 0 1 0 plane. Now the third one is a half, z axis is also the half one. So suppose we will get here half 1 and now take the intercepts of both the half planes and draw the perpendicular from there to there, and that point is nothing but 1 to 1 plane. Now how to draw the number of directions of a plane greater than 1 and 0. If for example 1 to 1, 1 to 3 or 1 to 4 like that, if the numbers is greater than 2, then first of all first step is divided by the maximum number. Maximum number is nothing but in this 1 to 4 as a 4. So first divided by 4, we will get 1 to 4 divided by maximum number as a 4. So 1 by 4, 2 by 4 and 4 by 4. Here this becomes 1 by 4, this is 1/2 and this one is a 1. And the third step, those axis or coordinate becomes a 1, that axis will take a upper direction. There is no any logic to take that axis in the upper portion, you can take at any direction, but this is only the simplicity to draw the directions of a plane as well as the better visualization of that particular axis. That is why we will take those axis becomes a 1 as a upper portion and then we can draw the particular axis. In this way we can draw the positive plane, negative plane as well as a greater than the coordinates greater than 1 and 0. I think that everyone understood about the directions and the planes of a Miller indices.